Next, we deal with the shear resistance of the staircase. The design for the shear resistance, it will be similar to the slab, as the cross-sectional areas is relatively large as compared to the loading acting onto it. For shear resistance, you may use these equations: VRDC and VRDC minimum. VRDC represents the shear resistance of the concrete, taking into account the amount of reinforcement bar provided. VRDC mean it will be the minimum resistance of the concrete alone. To acquire the shear resistance for both of them, you will need to find the factor K and also the percentage of the reinforcement. Now we're going to calculate those factors. The K factors is in the functions of the effective depth. We have calculated the effective depth, which is equals to 137 mm. Substitute into the equations, you get your K equals to 2.21. The K value must not be greater than 2.0, as implied by the equation. Therefore, we use K equals to 2. When the K that you have obtained is less than 2.0, then you use that K value. Otherwise, which in this case, when it is more than 2, you use 2.0. Next, we get the rho 1, which is the percentage of the reinforcement over the cross-sectional area. You need the area of reinforcement, which you have provided for the staircase, 574, divided by the effective areas. The B here, it will be on 1 meter unit width, and the D is calculated as 137 mm. That gives you the rho 1 equals to 0.0042. You know that the amount of the reinforcement bar provided is about 0.4% out of the effective cross-sectional area. You're going to check against the limit of 2%. If it is greater than 2%, you will assume your rho 1 equals to 0.02, which is 2%. In this case, it is less than that. You will use the value that you have obtained. Next step, it will be substituting the relevant value into the equation. FCK is given 25 megapascal, and then you obtain VRDC 72 kilonewton. You will do the same to find the VRDC mean. K calculated as 2, FCK 25, B 1000, D 137. You get the VRDC mean 67.8 kilonewton. The shear resistance of the staircase, it will be the larger value of the two. That means you will have VRDC equals to 72, since it is larger than the VRDC mean. Now that you have acquired the shear resistance, you're going to compare with the shear loads. How do you get the shear loads? You will have to get it from the reactions acquired from the free body diagram shown here. Use the principles of static equilibrium. Find the reactions here and here. Most likely, your maximum shear will occur here. Then your reactions, it shall be equals to the shear loads. Find the reactions and compare with the shear resistance. In this case, the shear loads is smaller than the shear resistance. That means the staircase is adequate to resist the shear loads without requiring the reinforcement for the shear, since these two equations are meant to check whether the shear reinforcement is required.